So in this video, we're going to talk about three things. We're going to talk about how to graph sine, cosine, and tangent. That's the goals. And we're going to talk about how to take our unit circle and how to use that to our advantage to create our functions for sine, cosine, and tangent. Now, I'm going to first off plot f of x is equal to sine x over here. So I'm going to have my x values along here, and then these are going to be my heights. Now, sine x, you can notice, is going to be an oscillatory function. So we call it a sinusoidal function as well because it's referring to, sine. It's referring to waves here. Now, you're going to notice that sine is going to have a range that's always going to be between 1 and -1 here. So it's going to be between this value and this value here for my y-coordinates. The reason for that is that sine always is your y-coordinate of your unit circle here. So what I want you to do is I want you to draw out this graph here, and I want you to make the unit circle over here, and I want you to line it up so it's perfectly lined up here. So right here, see how my y-coordinate is -1? I'm also going to make that be -1. See how my y-coordinate is 1 here? I'm going to line that thing up over here. So I'm going to call that value 1. Now these points were important. These 1, 2, 3, 4 points are important. What we see here is that point right there is 0 radians with respect to our angle. So that's 0 radians. Our next point would be pi over 2 radians, or 90 degrees. So let's call this, actually I'm going to shift it over a little bit more. This will be pi over 2. That's pi over 2. That's pi, or 180 degrees. Make sure they have the same, they're about the same distance apart. So that's pi, and then this goes to 3 pi over 2. And then it cycles back around onto itself, so it hits 2 pi. That's an important value as well. So those are our values of our concern here. Now, what we see here is that at 0, so when our angle is 0 radians right here, we see our sine is our y-coordinate, so it starts off at 0. So I stab it, that value is 0 here for our height here, so it's 0, 0. Centered at that. At pi over 2, what we see is that our y-coordinate is 1 here, so it must be 1 up top. At pi, or 180 degrees, its y-coordinate is 0. Notice how I'm just jumping up by 1 unit at a time. I'm not jumping by 2 here. That's an important aspect as well. Here it's -1. And then at 2 pi, it cycles back around on itself, so it hits 0 again. So it's at 0 again. It repeats itself right there. Now, what I wanted to show you is that, imagine this marker is my height. So this is my height marker, okay? And I'm going to make my height in reference to how many radians is going around. So this is how many, all right, so this is my y-coordinate. So, and this is going to be how many radians is going around over here. So right here it's 0, it's height. At pi over 2 radians, its height is 1. Same height, same height, same height. At pi radians, its height, the height of this blue marker is 0. At 3 pi over 2, these are all the same height throughout the whole thing. And then at 2 pi, it's 0. I probably should have made it a little bit more over here. I'm not perfect at this. All right, so it looks like that. So at 2 pi, it goes over here. So that's what our sine wave looks like. And as you notice right here, after 2 pi, it just repeats itself over again. So it cycles back around, so it goes on and on forever, still hovering between values 1 and -1. It is an odd function, so it kind of goes down and then up, and it repeats itself, so on and so forth. So like at -pi over 2, it would be -1. because you see that kind of pattern. It just repeats itself. Now let's go on to cosine x. Let's graph that. Okay, so if we're going to try and plot f of x is equal to cosine x. Cosine x is a little more tricky. It is symmetric looking, which is a nice aspect of it. Symmetric meaning it's like over here, it's the same thing on both sides with respect to that line. I'll show you what I mean by that. So right here at 0 radians, you know it's going to be 1. So it's still, its values are always going to be between 1 and negative 1 here. It's not going to be so easy to tell as, you know, our sine wave was considered, where it's going to be between 1 and negative 1, but it is kind of the same idea. So at 0 radians, its value is 1 because it's my x-coordinate. So it's the x-coordinate here. So it starts off right there. At pi over 2 radians, so we're over here now. So this is 0, this is pi over 2. It's 0. At pi, or 180 degrees, it's negative 1. Goes over here. Notice how we're jumping at 1 value at a time. At 270 degrees, or 3 pi over 2, its value is 0. And we know, we don't even have to look at that last one. It's 1, but you notice it's jumping up by 1 unit at a time, so it's repeating itself, so it looks like that. Value is always the x-coordinate here, and so we just connect our dots to be kind of like a wave. Here, I'm going to make it so it looks like this. And it keeps on keeping on for forever, and it goes back up around. And so what we see here is that is how you would plot the cosine function. So it would look like that. That's our cosine wave. Notice it hits negative 1 and 1, and that's how we would do that. All right, next, I want to talk about a chart for tangent, and then we'll talk about how to plot tangent. Tangent is defined to be as sine over cosine. So tangent of x is literally defined to be sine x over cosine x. Always, always, always. The important aspect of tangent, though, is that its domain, it takes on values where the denominator right here, that this can never be equal to 0. It says, I avoid dividing by 0. Because when we divide by 0, we run into problems. So this value right here can never equal to 0 in the denominator. So it says the domain can only consider values where that doesn't happen. So that must hold true right there. So if we're going to think about a chart here, let's say we have x over here. And let's say what we're wanting to do is we're wanting to figure out what tangent of x would be. And we were referencing radians here. So let's say this was 0. Let's say this is pi over 6. Next one would be pi over 4, or 45 degrees. Next one would be pi over 3, or 60 degrees. And then last but not least, it would be pi over 2. So we're thinking about values along our unit circle here. You know, pi over 6, pi over 4, and pi over 3. We're wanting to figure out what tan of 0 would be. Well, tan of 0, well, that's kind of hard to figure out, but we know what tangent's defined as. It's defined as sine of 0 over cosine of 0. Now, sine of 0 is just 0 because that's my y-coordinate there, so it's 0. And cosine of 0 is 1, so 0 over 1 is 0. So this value right here is 0. Now let's go on to tangent of pi over 6. Tangent of pi over 6 is the same thing as saying sine of pi over 6 over cosine of pi over 6. Sine starts at 0. Its next smallest value would be 1/2. So it would be 1/2 divided by, notice how my divided by sign is a little bit longer here. So it's 1/2 divided by cosine of pi over 6. You know it's going to be the longer side, so this would be square root 3 over 2 right here. So this value would be square root 3 over 2. Now, when you deal with fractions in this way, and this is very good for you to see this, because we're going to be going into trig identities and how to deal with fractions in this way. You're going to be just like that, solving these things. So to deal with fractions in this way, again, is I'm going to take this number right here. So if I multiply 2 over square root 3, 2 over square root 3 on both sides, the trick is to write this numerator up top. So that number is 1/2. And then I'm going to multiply that by, I'm going to take this value down here in the denominator and I'm going to flip it. So where 2 is on my middle finger, it's now going to be up top over here. So I'm going to take those values and I'm going to flip them. Notice the 2's cancel out, and you're left with, that must be equal to 1 over square root 3. Now, the issue is that we know that we don't like square roots in the denominator, so I multiply both sides by the numerator and denominator by square root 3. So in other words, it's square root 3 all over 3. So that value must be square root 3 all over 3. And that's how we do that one. So that's tangent of pi over 6. Trust me, they're all not that hard, but that was a fun one. Tangent of pi over 4. Well, that's sine of pi over 4 over cosine of pi over 4. Now, this is the value where my sine and my cosine values are both square root 2 over 2. So my numerator and denominator here are both square root 2 over 2. So they're both values square root 2 over 2 divided by square root 2 over 2. In other words, this value right here must be equal to 1. So my tangent of pi over 4 is 1 because my numerator and denominator here are created the same. So that's how we do that one. All right. Tangent of pi over 3 or 60 degrees. We know it's sine of pi over 3 over cosine of pi over 3. Now, sine of pi over 3, so it keeps on getting a little bit bigger each time. So it starts off at 1/2, square root 2 over 2, square root 3 over 2. It's the long side here. So we're looking at pi over 3. It's square root 3 over 2 for my y coordinate. So over here, up top, it's square root 3 over 2. And my cosine of pi over 3, that's the short side. So it's the half. A half goes there. I take my denominator and I flip it. So tangent of pi over 3, I take this value right here, I move it down, times, I take that value and I flip it. So it's 2 over 1. In other words, the 2's cancel out, so you're left with just square root 3. So tangent of pi over 3 must be equal to square root 3. That's how you do that one. The last one is my favorite one, tangent of pi over 2. Let's do that one. Tan of pi over 2. That value must be equal to sine of pi over 2 all over cosine of pi over 2. Now, sine of pi over 2 is 1. Cosine of pi over 2 is 0. That's a problem in mathematics you cannot divide by 0. Now, when we said our definition in the very beginning, we said our domain for tangent can never lead to this happening here. We said that this value down here can never equal 0. So the issue is that we don't have a definition for it, because this value right here is not in the domain, not in domain of tangent. So it doesn't make sense to talk about. So this situation never happens here. So in other words, its value is undefined. We have no idea what tangent of pi over 2 is. It's undefined. It doesn't make sense to talk about because it would lead to division by 0. It's not equal to 1 over 0. It's literally, it's not defined. It's not in the domain of tangent. That's how we establish our chart here. Now I want you to look at this value here. And I want you to look at this value here. Tangent of 0 is 0. And tangent of pi over 4, where our sine and our cosine values are the same, is 1. So when we're going to plot tangent, those are some very important points that we're going to focus in on. All right, so let's plot tangent. Finally, let's get into our plot for tangent. All right, let's see if I can save some of my circle here. All right, so it looks like this. All right, that value, it's going up 1, so it's 0, 1. This value is 1, 0. All right, there's my unit circle. Now we're going to get into plotting tangent x. Now tangent is not going to be, it's not going to have a range between -1 and 1. So when you make tangent, it's not going to be restrained between these values over here. It's not going to be, you know, between those. It's going to go off. It's going to be unbounded. It's going to go off to infinity and beyond. It's going to go way up top. So you can't really use the idea that this is -1 and this is 1 over here. It doesn't really work out that nicely as a concept. So the important values for tangent is that its value over here at pi over 2. So if we're at pi over 2, right here, its sine and cosine term were the same. So that value, sine over cosine, were the same. Sine over cosine is the same, so it must be 1 right there. So we talked about that being 1. Actually, sorry, I meant to say this. At pi over 4, sorry. At pi over 4, let me repeat myself. This was pi over 4. So my sine of pi over 4 and my cosine of pi over 4, you know, that being my x-coordinate cosine, that being my y-coordinate sine, you're doing the same. You're going square root 2 over 2 over square root 2 over 2, so its value is 1 right here. So at pi over 4, it's 1. Now at pi over 2, we said it doesn't make sense to talk about it, but we're going to plot, we're going to have that value declared on our graph here, and we're going to see where it kind of goes. At tangent of 0, we discussed why that value is 0. So it's right there. Because it's sine over cosine, so its sine is 0. 0 over 1 is 0, so that's that value right there. At minus pi over 4, so we're looking over here, we see that our value for cosine would be square root 2 over 2, and our value for sine would be negative square root 2 over 2. And what you notice here is that you're still doing the same numerator divided by the denominator, except it's just going to be negative here because it's got that negative sign. So it's going to be right here. This value is going to be -1 over here. So a -1, that's where that value is going to be for negative pi over 4 over here. Now, if you notice right here, if we look let's say, it doesn't make sense to really talk about the unit circle over here, but here. I'm wanting to get at a particular region of it. I'm just making myself more room. All right, so this is going to be negative pi over 2 over here. This value is going to be pi over 2 over here. Okay, so what I'm going to do now at this for these values over here, when my sine value, so this is at sine of pi over 4 over cosine pi over 4 is 1. And as it gets super close to pi over 2, so at pi over 4 it's here, at pi over 6, at pi over 3 it's going to be way up here, and then it's going to keep on going up. It's going to keep going up. And the reason why it's going up here is that if we take a value that's extremely close to pi over 2, so let's say it's a value that is very, very close to pi over 2. It's just a little bit short of it. So it's just a value a little less than pi over 2. So it's about pi over 2. So it's about right here. And it's on the right-hand side over here. So as it's getting over here, what you're going to notice is that just eyeballing the thing, if you think about a triangle here, and that value is almost about pi over 2. This value up top, its radius is going to be 1. That looks like its sine term, its height is about 1. So it's about approximately 1. And as it gets very close over here for sine over cosine, the cosine term, the x-coordinate, is a very small number. So it's like 0.001. So what you have here is you have a value for tangent. It's going to be a value that's going to be 1 over 0.000, it keeps on going, 1. So it's 1 over a really small, tiny positive number. And we discussed that concept is that this number becomes huge. Whenever you have an extremely small, tiny positive number, this thing, it blows up. So it's like 10 gajillion. So as this value gets smaller and smaller, closer and closer to pi over 2, its value becomes, so it's like, it goes way off to infinity. And it never hits it because it's never defined at that value. So, but tangent, it looks like this. So here's what tangent looks like. It goes way up, pi over 2, then it goes down. So it kind of looks like this. So this is what my tangent function looks like, and my asymptotes are at pi over 2, because it never hits those values, because it leads to division by 0, so you have these lines here. And then tangent, it actually repeats itself, so it keeps on, it does the same thing over here, and it does the same thing over here, and it just keeps on repeating itself over and over again. Okay, so that's how we plot what tangent of x would be. So this would be f of x equal to tangent x. So the important thing is to know that at pi over 4, my value for tangent is 1. And as it goes closer and closer to pi over 2, its value becomes infinity, and it goes straight up. It goes, the limit approaches infinity as it goes to pi over 2 there. And at negative pi over 2, it goes down to negative infinity. So I hope this video kind of helped with that explanation for there.